So on page 38, we have a warm-up for the quiz you are taking today over how to describe where in the atom electrons are. So we're going to, again, if you haven't had class time yet to do the warm-up, you should pause the video. This should take you about 8 minutes. 8 minutes, pause the video, do the warm-up, then I'll talk about it. Alright, and now if the video is playing, you should have had 8 minutes to finish or mostly finish the warm-up. And so what we're looking at here is they're giving you an element. You have to do the Lewis dot structure, the orbital notation, electron configuration, and noble gas configuration. So it's a lot of different things, but we'll start with fluorine and orbital notation. Remember that the periodic table is your roadmap, and you always start at hydrogen. Hydrogen's in the 1s section, so I'm going to write a 1s. And by now, hopefully you know how many blanks you're supposed to draw for S. Remember, the number of blanks is dependent on the letter. And when you have S, going back to our notes on page 31, when you have S, there is one blank. So I'm going to draw one blank. Each blank gets 2 electrons in it, so I can draw 1, 2. Remember to draw one up and one down. That takes me through helium. I haven't gotten to fluorine yet, so I go to the next row. Now I'm in the 2s section, so I'm going to write 2s. Again, the number of blanks depends on the letter, so if I'm looking at S, I get one blank. And again, each blank gets 2 electrons, one up and one down. I still haven't gotten to fluorine yet, so I go across to the next section. This section is 2p. So I'm going to write 2p. And p's get 3 blanks. So I'm going to draw 1, 2, 3 blanks. And I have to make sure I don't write too many electrons at this point. Fluorine is only supposed to have 9. It's atomic number 9. That's going to be 9 protons and 9 electrons. I already have 1, 2, 3, 4 electrons. If I'm going only up to 9, then I should only be drawing 5 more. So, if I only need 5 more, then I'm going to put the first one in here. And I have to remember the good mother rule. I don't make electrons share if there are empty rooms. So here's one of the 5 I needed. The next one's got to get its own room. And the next one's going to get its own room. Now, all the rooms have somebody in them. Now I can make them share. So we go down and down to share. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. Fluorine, again, is only supposed to have 9. So this is where I stop. For the electron configuration, I just write what I see here. I see 1s, I'm going to write 1s. There are 1, 2 electrons, I'm going to write a 2. I see 2s, I write 2s. There are 1, 2 electrons, I'm going to write a 2. I see 2p, I write 2p. There are 1, 2, 3, 4, 5 electrons, I'm going to write a 5. Easy enough. And then for noble gas configuration, there's a couple different ways to do it, but on your quiz, you're not going to have that list from your notes of what each noble gas is. So you're going to have to remember, first of all, that the noble gases are this section on the periodic table, this very last column. And then what we do is we look at fluorine, and we go backwards until we hit a noble gas. So fluorine's number 9, go backwards, number 8, 7, 6, 5, 4, 3. None of these were noble gases, but when I get to element number 2, helium, that's a noble gas. Helium's in the 1s section. It is number 1, 2. So helium is just 1s2. That's what I know from the periodic table. which means that instead of this 1s2 right here, I can just write helium in brackets. And then this leftover 2s2, 2p5, I still need to write, because that is not part of helium. The 2s2, 2p5, that's part of fluorine. Now what's important is to not forget to do the Lewis dot. On the quiz, I guarantee at least 5 of you are going to forget to do the Lewis dot on the left here. Don't forget to do it, okay? There are 2 ways you can figure out how many dots you need. One way is to look at your electron configuration, find the biggest number, like of the front numbers, 1, 2, or 2, bigger than 1 is 2, and the number of electrons in there, 2 and 5, 2 plus 5 is 7, that means I'm going to need 7 dots. Of course, you could also just look at your periodic table, see that fluorine is in the 7th group, the 7th column, and that also tells you need 7 dots. So 1, 2, 3, 4. Remember, you have to put 1 on each side. Then you go back and pair them up. Now, some people get tempted to put all 9 of fluorine's electrons on there. Don't do that. You should never have more than 8 dots. The dots are the valence electrons, only the ones on the outside, the furthest outside the highest energy. There should never be more than 8 dots. Okay, let's look at calcium. Calcium's orbital notation, again, we're always going to start at the beginning of the periodic table where hydrogen is, which is the 1s. So I write a 1s. S gets 1 blank. All the s's get 1 blank. And I put my 2 electrons in there. 1s takes me through helium. Then I go to the next row where I'm at 2s. So I write a 2s. Again, s's get 1 blank. And we need 2 electrons in there, 1, 2. After 2s, I come across to this section, which is 2p. So I'm going to write 2p. P's, again, get 3 blanks. So I'm going to draw 1, 2, 3. And calcium, by the way, we need 20 electrons. And so far we've only got 4. So I'm going to end up filling all these blanks. Again, don't forget the good mother rule. Put 1 in each blank before you go back and pair them up. The good mother rule, also called the Pauli exclusion principle. No, Hund's rule. I said that wrong. That's Hund's rule. Anyway, everyone gets its own room before you go back and pair them up. When we get to the end of 2p, we now still only have 10 electrons. 2, 4, 6, 8, 10. So I got to keep going. Next row is 3s. So I write a 3s. s's get 1 blank. And I can put 2 electrons in there. I'm up to 12. I need 20, so I got to keep going. I go across to the next section. This section is 3p. So write a 3p. Again, p's get 3 blanks. And this is only going to take me to 18 electrons, so I'm going to have to fill all of these as well. Two, 4, 6, 8, 10, 12, 14, 16, 18 electrons. Calcium, I'm going to need 20. So I have to go one more section. After I get to 3p, go down to the next row, and we're looking at 4s. S gets 1 blank. And I need 20 electrons. I've already got 18, so I add the 19th as an up, add the 20th as a down. Now, if we had to keep going past calcium, we would have entered 3d. And remember, D's get 5 blanks. Just in case that happens to come up on your quiz, remember that if you need D's, they get 5 blanks. There's a order to it right. 1, 3, 5, 7. It's just your odd numbers for how many blanks you have for each letter. Okay, electron configuration. Again, we write what we see. 1s, there are 2 electrons. 2s, there are 2 electrons. 2p, there are 6 electrons. 3s, there are 2 electrons. 3p, there are 6 electrons. 4s, there are 2 electrons. And for noble gas configuration, I need my periodic table again. I find calcium and I go backwards till I hit a noble gas. Calcium's number 20, not a noble gas. Go backward to 19, still not a noble gas. Go backward to 18. Oh, this is a noble gas. Remember, these are the noble gases, this very last column. So argon is the one I'm going to be substituting in, so I can write argon in brackets. And then I have to figure out how much of this is argon. Well, let's start to the beginning, always. And then if I look at the section argon's in this 3p section. And it is 1, 2, 3, 4, 5, 6. Which means from the beginning through 3p 6 is argon. So from there to there, that's argon. When I write argon, it's the same as writing all of that junk. Just shorter. But this 4s2, that's past argon, that's not part of argon, that's just part of calcium, so I still have to write that part. For the Lewis dot structure, again, don't forget to do the dots. 2 ways to do it. You could look at these big front numbers here and find the largest one. So you've got 1, 2, 2, 3, 3, 4. Biggest of those is 4. However many electrons are in the 4, that's how many dots I'm supposed to draw. So there's only 2 electrons, that's 2 dots. Remember to put 1 on each side. Of course, the other way you could do it is you could look at your periodic table and be like, calcium, it's in the second column, second group, so that means it needs 2 dots. Identify the atoms through the use of their arrangement of electrons. It wants to know basically what element. What element are these? So 1s2, 2s2, 2p6, 3s2. There are a couple ways you could do this as well. You could follow your periodic table. 1s2 would be hydrogen and helium. Keep going to 2s2. Here's 2s, there's 1, 2, would take you to beryllium. Move over to 2p. Going through 1, 2, 3, 4, 5, 6 would take you to neon. And then going to 3s, 1, 2, takes you to magnesium. That's one way you could do it. The other way is you could add up all of these numbers of electrons. 2 plus 2 plus 6 is 10 plus 2 is 12. And element number 12 is magnesium. 2 ways you can get to the same answer. Looking at part B, again, there's 2 ways you could do it. You could actually physically use your periodic table. It says you're starting at krypton and then moving on to 5s2, 4d10, 5p5. So here's krypton. Next is 5s12. That takes you to strontium. Then it said 4d10. So you go, here's 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 5p5, come to the 5p section. 1, 2, 3, 4, 5. That's iodine. The other way you could do it is, again, you could add up all of the electrons here. There's 2 plus 10 plus 5, so 2 plus 10 is 12, plus 5 is 17. Don't forget to also add the ones from krypton, though. Krypton has 36. So if we do 36 plus 17, you get 53. And element number 53 is iodine. Again, 2 ways to get the same answer. Number 3 says, draw the Lewis valence electron dot symbol for an atom with an electron configuration of 1s2, 2s2, 2p3. You need to figure out which element this is. And again, there's several ways to do it. The fastest way is probably to add these up. 2 plus 2 is 4, plus 3 is 7. So your element that has 7 total electrons is nitrogen. And then the dot structure would be putting on the dots for its valence electrons. So if we look at the electron configuration, looking at these front numbers, 1, 2, 2, you need the biggest, which is 2. So you need the numbers of electrons in the 2 sections, which would be this 2 and this 3. 2 plus 3 is 5. That means you need 5 dots. Or, of course, you could look at your periodic table. Nitrogen's in the 5th group. It needs 5 dots. So you go 1, 2, 3, 4, 1 on each side. 1, 2, 3, 4, 1 on each side. Then you can pair them up. Finally, for number 4, it asks how many electrons will fill the orbitals depicted to the right. Well, S can have 2 electrons, and that's true for 1s and for 2s. So that's 1, 2, 3, 4 electrons. They ask why, because each orbital can hold 2 electrons, and there are 2 orbitals. So 2 times 2 equals 4. All right, at this point, unless Miss Woodlock says otherwise, it's time for your quiz.